Earth, a planet in constant motion. Our planet is always changing. Mountains rise and erode, oceans form and disappear. This transformation is driven by powerful forces. Wind, water, and tectonic activity shape our world. Sedimentary rocks tell stories of ancient environments, formed from tiny particles of rock and organic matter. Weathering breaks down rocks, transported by wind, water, and ice. They settle over time, forming new layers. These rocks are a testament to Earth's dynamic nature. The crumbling giants, weathering and erosion. Imagine a towering mountain range, sculpted by the forces of nature over eons. Wind, rain, and ice relentlessly wear down these giants. This process is called weathering. It is the first step in the creation of sedimentary rocks. Physical weathering acts like a sculptor's chisel. Water seeps into cracks in the rock. When it freezes, it expands, causing the rock to break apart. Temperature changes also contribute to this process. The constant heating and cooling cause the rock to expand and contract, leading to fractures. Chemical weathering is more subtle but equally powerful. Rainwater is slightly acidic and reacts with minerals in the rock, dissolving them. This weakens the rock's structure, making it more susceptible to erosion. The type of rock greatly influences how it weathers. Some rocks are more resistant than others. Erosion then steps in as the transporter. Wind carries away loose particles and rain washes away soil and sediment. Glaciers, like powerful rivers of ice, carve through mountains carrying massive amounts of rock and debris. Rivers of rock transportation and deposition. Once weathered and eroded, rock fragments embark on a journey. They travel with the wind, water, or ice. This transportation process is crucial for sedimentary rock formation. It redistributes Earth's materials over great distances. Rivers are like conveyor belts of sediment. They carry vast quantities of sand, silt, and clay downstream. As the river flows from the mountains to the sea, its energy changes. In the mountains, the river is fast and powerful, carrying large rocks. As the river approaches the sea, it slows down and loses its energy. It deposits the heavier sediments first. The lighter sediments, like silt and clay, are carried further and deposited in calmer waters. This sorting process creates distinct layers of sediment. These layers are a hallmark of sedimentary rocks. Wind is another important transporter, carrying dust and sand across continents. Think of the Sahara Desert, where wind-blown sand creates vast dune fields. These dunes can eventually harden into rock, preserving the patterns of the wind. Glaciers, with their immense power, transport huge boulders and piles of debris. They deposit them far from their origins, creating unique landforms. A pressed history, compaction, and cementation. Over time, layers upon layers of sediment accumulate in depressions called basins. The weight of the overlying layers puts immense pressure on the layers below. This pressure compacts the sediments, squeezing out the water trapped between the particles. This process is compaction. Imagine burying a sponge under a heavy book. The book's weight would squeeze the sponge, making it flatter and more compact. Compaction alone is not enough to create solid rock. Another process is needed: cementation. Groundwater, carrying dissolved minerals, seeps through the compacted sediments. These minerals, often calcite, silica, or iron oxide, crystallize between the sediment particles. They act as a natural cement, binding the particles together. The type of cementing material influences the rock's color. Compaction and cementation, working together, transform loose sediment into solid sedimentary rock. This process takes thousands, even millions of years. The result is a rock that preserves a record of Earth's history. Section 5. Nature's time capsules, the formation of fossils. Fossils are the preserved remains or traces of ancient life. They are found in sedimentary rocks. They offer a fascinating glimpse into Earth's distant past. Fossils form through a combination of specific conditions. These conditions are not common, making fossils valuable to scientists. When a plant or animal dies, its remains usually decompose quickly. However, if the remains are buried rapidly in sediment like mud or sand, the decomposition process can be slowed down or even stopped. This rapid burial is often triggered by events like mudslides, volcanic eruptions, or floods. Over time, more sediment layers accumulate, burying the remains deeper. The pressure from the overlying layers, combined with the mineral-rich groundwater, leads to the fossilization process. Some fossils preserve the actual hard parts of the organism, like bones, shells, or teeth. The minerals in the groundwater replace the original organic material, creating a rock replica of the organism. Other fossils are impressions or traces of the organism's activity called trace fossils. Examples include footprints, burrows, or even fossilized feces known as coprolites. Section 6. Whispers from the past. What fossils reveal. Fossils are like puzzle pieces. They help us reconstruct Earth's history. By studying fossils, scientists can learn about the types of organisms that lived in the past. They can also learn about the environments they lived in and how life on Earth has changed over millions of years. For example, fossils of marine organisms in rocks found high up in the mountains tell us that these areas were once submerged underwater. Fossils of tropical plants in Antarctica indicate that this now frozen continent was once much warmer and supported lush vegetation. Fossils also help us understand evolution. By comparing fossils from different time periods, scientists can trace the lineage of different species and see how they have changed over time. The fossil record provides evidence of extinct creatures, like dinosaurs. Section 7. Ancient sunlight, modern energy, the origins of fossil fuels. Fossil fuels are a dominant source of energy. We use them for transportation, electricity, and heating. They may seem like modern conveniences, but fossil fuels actually have their origins in ancient biological processes. They formed over millions of years from the remains of dead plants and animals. The formation of fossil fuels began millions of years ago. Back then, the Earth was a much warmer place. Lush forest covered much of the land. Oceans teemed with microscopic organisms. When these organisms died, they sank to the bottom of the oceans or were buried in swamps and bogs. Over time, layers of sediment like mud and sand piled up on top of these remains. Section 8. Coal. The compressed legacy of forests. Coal is a black or brownish-black sedimentary rock. It is combustible and primarily composed of carbon. Coal formed over millions of years from the accumulation of plant matter. This plant matter accumulated in swampy environments. Imagine prehistoric forests teeming with giant ferns, towering trees, and dense undergrowth. When these plants died, they fell into the stagnant water of the swamps. The water was oxygen-poor, slowing down the decomposition process. Over time, layers of dead plants accumulated, forming a dense, waterlogged material called peat. As more sediment piled on top of the peat, the pressure and heat increased. This caused physical and chemical changes in the peat. The peat gradually transformed into coal. The longer the coal is subjected to heat and pressure, the higher its carbon content and energy value. There are different types of coal. They are ranked according to their carbon content. Lignite is the lowest rank of coal. It is soft and brownish in color. Bituminous coal is a higher rank of coal. It is harder and black. Section 9. Oil and natural gas. From tiny creatures to vital resources. Unlike coal, which forms from plant matter, oil and natural gas formed from the remains of tiny marine organisms. These organisms include algae and plankton. They lived millions of years ago in the Earth's oceans. When these organisms died, they sank to the ocean floor. Over time, they were buried under layers of sediment. Similar to the process of coal formation, the heat and pressure from the overlying layers transform the organic matter. However, the transformation process for oil and natural gas differs from coal. The organic matter in this case was subjected to even higher temperatures and pressures. This resulted in the formation of hydrocarbons, which are molecules composed primarily of hydrogen and carbon. Oil, also known as petroleum, is a liquid mixture of hydrocarbons. Section 10. A vast timeline. Millions of years in the making. One of the most astounding aspects of sedimentary rock and fossil fuel formation is the immense timescale involved. We're talking about processes that take millions of years. Consider the layers of a canyon wall. Each layer represents a period of deposition, potentially lasting thousands of years. The oldest layers, at the bottom, were laid down first. The youngest layers are at the top. This layering of sedimentary rocks is like a timeline of Earth's history. The formation of fossil fuels also takes place over incredibly long periods. The accumulation of organic matter, the burial under sediment, the transformation under heat and pressure, all these processes occur over millions of years. For example, the oil and natural gas we extract today formed from organic matter that accumulated in the Earth's oceans millions of years ago. This vast timescale highlights the importance of managing these resources responsibly. Section 11. Rocks, fossils, fuels, pieces of Earth's story. Sedimentary rocks, fossils, and fossil fuels are all interconnected. They are all products of Earth's dynamic processes over millions of years. Understanding these connections gives us a deeper appreciation for the planet we live on. Sedimentary rocks provide a record of past environments, climates, and life forms. Fossils, found embedded within these rocks, offer glimpses into ancient ecosystems and the evolution of life. Fossil fuels, also found in sedimentary rock layers, are a testament to the immense stores of energy derived from ancient life. The next time you hold a rock, consider its journey. It might have been part of a mountain range, transported by rivers, deposited in an ancient sea, buried under layers of sediment, and transformed over millions of years. These natural wonders remind us that Earth is constantly changing.